For our next special quadrilateral conversation, we're going to be talking about rhombi, which is the plural of rhombus. And down here I have a picture of a rhombus, and first we'll discuss what they have in common with parallelograms. Well, just as every rectangle has the same characteristics, so does the rhombi. It has opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, the consecutive angles are supplementary, and the diagonals still bisect each other. And now we have an extra feature. First is that all four sides are congruent. The fact that all four sides are congruent will make things very easy to deal with. Next, we'll talk about the diagonals. The diagonals are going to meet perpendicularly, so they'll form a right angle right at that intersection. And then what is most convenient is that the diagonals bisect these opposite angles. So both of the little angles at the opposite corners here are going to be identical. So these are the same as each other, and these little guys are the same as each other. So again, working with rhombi are just going to be, it's actually a lot easier than working with a parallelogram. So there we have it. The additional three pieces for a rhombus is that all four sides are congruent, diagonals are perpendicular, and the diagonals bisect the opposite angles. Now let's not confuse the additional piece about rectangles, how the diagonals are congruent. That's not the case for rhombi. It would be these facts from parallelograms plus these three. All right, let's move on. So for number 2 and every other question after this, we have to answer this question right here. Is this question dealing with segment, lengths, or angles? So I'm looking at all four of these, and undoubtedly we are talking about segment lengths. So I'm going to think about what I know about segments. I know that all four of these are the same. I know that the diagonals bisect each other. So this is what I know for a fact about all of the segments that I see in this picture. Now let's go ahead and put in the numerical values that they gave me. Well, they gave me that EF was 23, so I'm going to put 23 right here. And then they gave me that DF was 40. If DF is 40, then this is 20 and this is 20. Now what is critical is that I remember that diagonals meet perpendicularly. So this concept of E to F to H is a right triangle. This is 20 units long, this is 23 units long, and this is I don't know. Now remember, my hypotenuse is always opposite the right angle, so that would be that x squared plus 20 squared equals 23 squared. And now I can go ahead and solve for x. So press pause and solve for x. Again, press pause and work out the value of x for yourself. Watching me do it and simply writing the numbers is not productive in building up your mathematical and cognitive skills. So press pause and really do the work throughout the video. Okay, so what I end up with for x is 11.4. Now where is that? That's this piece right here, which is this piece right here, which is this piece right here. I also know that this is 23 all the way around, so I think we can answer just about anything at this point. So from G to F, from G to F, it's obviously 23. From H to F, it's right here, it's obviously 20. From G to H, it's right here, it's 11.4. And from G all the way to E is two 11.4s, and that's going to be 22.8. And that's about it. Now the key piece is to make sure that you're paying attention to this given piece of information was D all the way to F. Sometimes we're going to give you that whole diagonal, sometimes we're going to give you the half diagonal. So pay attention to what portion of the diagonal you've been given. Sometimes you have to double it, sometimes you have to divide it by 2. Again, pay close attention as to whether you've been given the entire length of the diagonal or just half. That will dictate, right? That will dictate whether you need to multiply or divide by 2 to get, that should be to be, the rest of the pieces, right? Don't forget to think. and just a quick little edit, right, to get the rest of the pieces. All right, let's move on. First and foremost, complete number 1 first, right? Then move on with me to number 3. So press pause and do number 1. Now again, is this question dealing with side lengths or angles? So I'm looking here and it looks like these are all segment lengths, okay? And this is a rhombus, so again, this is the same all the way around. These two are the same, and these two are the same. And this meets perpendicularly. All right, that's what I know about the side lengths. Let's get moving. RT has been given as 22 units. So that's all the way from R all the way to T. So again, that's the entire diagonal. So this is going to be 11 and 11. And this meets perpendicularly. US is 18. So from U all the way to S is 18. So that makes this 9 and 9. So now what I'm thinking is this triangle UVT is 9, 11. The right angle's here. I'm missing this length, which is directly across from the right angle. That makes that the hypotenuse. So 9 squared plus 11 squared equals x squared. Now, you finish this one. Remember, press pause, solve x for yourself. Watching me do it is totally pointless and fruitless. Press pause now and work out the value of x. And while you're at it, why don't you go ahead and finish the whole problem. Then press unpause. Okay, so what I landed with was about 14.2. So this section right here is 14.2. That's UT. So 14.2 goes here, here, here. Let's go back and fix this one up. And here. And so I think we have all of the lengths. So we come over for our final answers. V to T, that's right here, 11. U to V, that's right here, that's 9. RS, that's 14.2. And S to T, that's over here, that's again 14.2. All right, so at this point we should have 1, 2, and 3 complete. Number 4, is this dealing with segment lengths or angles? It looks to me like every question here has angles with it. So I think this is all about angles. So what do we know about angles? Well, we know that the center angle is 90 degrees. I know that this is 38 and that this is the same, and so are these. So those are all 38. And then I know that these little guys here are the same as each other. And so really what I want to know is, what's the big angle right here? Well, it's 38 twice. So 38 and 38 is what? Take a moment and double it yourself. You should get 76 degrees. So over here is 76. Remember that I always write the big angle on the outside and the little angles are right here. So that's 38 and 38 right here. Now 180 minus 76 will get me that other consecutive interior angle, right? So I'm going to write the big values out here. But again, 76 and this value that I'm about to write right here should add up to be 180. And I get 104 degrees when I subtract that. So this is 104 degrees and this is 104 degrees. Whoops. Now to get the little values inside here, I'm just going to take half of 104, which is going to be 52. So this is 52 degrees, 52 degrees, and then these are also 52 and 52. So this happens pretty quick. So the measure of angle 1, as according to our drawing, is 52 degrees. The measure of angle 2 is also 52 degrees. The measure of angle 3 is 38 degrees. This one was the easiest one in the whole thing. We could have just answered it right out of the box. As well as angles 4 and 5 are also 38 and 38. Angle 6, 52 degrees. Angle 7, 52 degrees. And angle 8, of course, another one that we could have answered right out of the box. That's just one of our characteristics of rhombi. Angles at the point of intersection of the diagonals are always going to be 90 degrees because diagonals are perpendicular. And there you have it. Piece of cake. There is a lot of repetitiveness in the angle explanations of rhombi. Let's move on. Now, as we deal with this question of is it dealing with segment lengths or angles, and what you'll notice is that on number 5, there's actually both, right? We have both coming at us. Hence, I have the drawing twice. Now, I would recommend that I would draw the picture twice. Once to deal with the angles and once to deal with segment length questions. Otherwise, the picture will get too busy and you'll make mistakes as a result of being unwilling to do a little bit of extra work. Now, let's get busy solving the problem. First, let's deal with the side length information. I got zy is 34, so of course that means 34 all the way around because a rhombus has 4 congruent sides. And wy is 38. So when I take half of 38, right, I'm going to get 19. So if wy is 38, then wv is 19, and this is 19, and that's going to be 90 degrees. We're definitely going to take this zvy, right, so that's zvy. And what do we have? We have that this is 19 and that this is 34, and we need to solve for this. So again, here's my right angle. That's my hypotenuse, so that's x squared plus 19 squared equals 34 squared. Press pause, solve for yourself. I get approximately 28.2, so that's 28.2, that's 28.2, and of course we'll need 28.2 times 2, which is 56.4. They're bound to ask us for that. And now I think you have enough information to go and answer all of the questions on the page. So finish that, you're on your own. Onward and upward over to the angle business. Now notice again, they're only going to give us one angle. Why? Because with one angle, we should be able to get everything else. Now, of course, in the center, these are all 90, 90, and 90. So I'll just kind of put 90 right there. zxy, that's from z to x to y. So the 34 is this angle right here, right? That's 34 degrees, which means this is 34 degrees, and this is 34 degrees, and this is 34 degrees. And the big one on the outside, of course, is going to be 34 twice, so it's 68 and 68. 180 minus 68 will get me the outside, so we'll say 180 minus 68 is 112, so that's 112 here and 112 out here, and half of 112 is 56 and 56, 56 and 56. Now, just for ha-has, in this triangle right here, if we took the 90 degree angle here, does 90 plus 34 plus 56 add up to be 180? Well, 6 and 4 is 10, carry the 1. 10 and 3 is 13, plus 5 is 180. Boom. So I think we're pretty solid on the angle measurements. Again, fill in the rest of the answers requested for number 5, and you're onward and upward. The only way you could mess this up is if you're having trouble reading 3-lettered angles, in which point you should ask me for help in class. And now we're on to squares. Perfect. This is going to be the easiest of all. Why? Because squares have the properties of all parallelograms. They also have the 4 right angles and congruent diagonals from rectangles. And then it has the perpendicular diagonals, 4 congruent sides, and bisected opposite angles from the rhombi. All right. So here's all of our parallelogram stuff. Here's the rectangle stuff, and here's the rhombi stuff. So I have 3 different squares drawn here at the bottom just to incorporate what we're talking about. So from parallelograms, we knew that this side was the same as this side, and these 2 sides are the same. Now, because it has 4 congruent sides, then that's the case. And also, because it has 4 right angles, we could say that, hey, this is a right angle, this is a right angle, this is a right angle, this is a right angle. Now, so not as to get too busy, I'm just going to kind of slide over to another one just to highlight a few other things. The diagonals bisect each other, but also it has congruent diagonals from the rectangle property, so I know that all 4 pieces are the same. And while we're here, we know that the diagonals from the rhombi characteristics bisect the opposite angles, so this is the same as this. But since they're all right angles, then I guess all of the bisected pieces are all identical. So all four of these little guys are the same. In fact, they're always going to be 45 degrees. Why? Because the big one is always 90 degrees. So this is 45, 45, and this is 90. And don't forget originally that these sides are parallel to each other to begin with. I think that just about covers everything that we got inside here. Again, 90 and 90 all the way around. And what's 90 plus 90? Consecutive interior are still supplementary, right? We still got that supplementary relationship. And opposite angles are still congruent, right? We still have that. So squares are going to be super, super, super easy. Let's move on. Okay, first thing I'm going to ask myself in this, are we dealing with lengths or angles? And I think the answer to that question is both. If you look at your answer key, or the answer section, there's both segment and angle pieces. So again, be willing to draw two identical pictures. Okay. All right, we want to draw a second picture to avoid confusion and busyness. Now, the first thing you should notice is that, wow, they've given me but one piece of information, that TR is 17. So this piece right here is 17, which makes this 17. Also makes this 17 and this 17. Well, I guess if we want to find the length of one of the sides, we're going to just take the fact that this is a right triangle and just extract that like this. And say, well, if that's 17 and that's 17 and that's x, that's our hypotenuse. Then 17 squared plus 17 squared equals x squared. Go ahead, you solve for x, press pause and get back to me. And you should get that roughly x is 24. So what is that? That's this outside piece right here, QR is 24. So that's 24, that's 24, and that's 24. And the rest of the questions for this should be pretty straightforward. Now, as for the angle business, they haven't given us any information. Why? Because it's always the same in a square. That's 90, and these little guys are always 45 degrees. So all you really need to do is figure out which piece are they asking about, right? This is about reading carefully, right? This is always going to be 90, and the little guys are always going to be 45. And 90 will always be at the point of the perpendicular bisectors intersection. Okay? So finish number 7 on your own, and then let's move on to the bigger and better algebra versions. So what do we have here? I see 9x minus 77 and 3x plus 7. I don't see any angle or degree marks here, so this can't be angles. This must be dealing with segment lengths. And more importantly, these are sides. And what do I know about the sides of a rhombus? They're all the same. So 9x minus 77 equals 3x plus 7 because they are congruent. And when they're congruent, I set the terms equal. So you should be able to get a value for x without a problem. Once you get the value for x, you should be able to substitute that into either one of these to get this side length and this side length. And because it's a rhombus, those side lengths are the same as these. In fact, they're all the same. So finding MP should be a piece of cake. You finish that one up on your own. Check that one in with me when you check in with your notes. If you got any questions, feel free to come up immediately. And what do we have here? Find the measure of angle FED. FED is right here, right? And this is a rhombus, so I know that this is the same as this. And these guys are the same as themselves. I know that angle D and angle E are supplementary. I know that angle F and angle E are the big angles at those. These are also supplementary. So that'll be helpful in the finding of the measure of angle FED. But how do I get the measure of this big angle? It would be helpful to know what x is. And again, I know that this angle was totally bisected because it's a rhombus and diagonals bisect the opposite angles. So 5x plus 1 is equal to 8x minus 20. Now, I don't know what they add up to be. Doesn't matter in a rhombus. I know they're identical, so I should be able to get a value for x. Once I get that value for x, I come and I substitute it in right here. That'll give me this half piece. It'll also give me the same exact half as that. But I think I want to double check and put x in here so that I do see that I get the same number twice. Once I have that, I'll have the measure of the whole angle. And once I have that, I can subtract it from 180 using that supplementary relationship to get the measure of angle FED over here. So that's a little bit of work, but you can do it, no problem. Let's move on. Finish that one, press pause, and then unpause it when you're ready. Number 10, what's most important is this is a square. So when I go to include that big question, is this lengths or angles? Well, we know this is going to be a cinch. Now I'm looking and they're giving me SW, VT, WU. These all seem like segment lengths. So let's put them in the picture. WU is right here. That is 8x minus 41. Okay, and SW is up here. It's the other part of that diagonal. This 2x plus 13 is right here. And what do I know about those diagonals? You said it. They're identical because diagonals bisect each other. In fact, all four pieces are the same because it is a square. It has that characteristic from the congruent diagonals of a rectangle. So what do I know? Well, since I know that they're identical, 2x plus 13 equals 8x minus 41. Now I'm going to get a value of x, which will allow me to get the length of this piece. And if I substitute that value of x into both of these, I should get the same number. So I do want to substitute it into both and get the value of those two pieces. Once I have that, I have the length of the entire diagonal, which means I have the entire other diagonal here, which is what they want to begin with. Okay, next. Again, I noticed that I have a square, so I'm excited to be able to answer the question about segment lengths or angles because this should be a breeze. I see this degree mark piece over here, so I know that I'm dealing with angles. Now again, remember, this angle right here is always going to be what measurement? Half of 90 degrees, right? So 7x plus 3 is equal to what? Should be 45 degrees. Now what? Just solve for x. Why don't they ask for any angle measurements? Because you wouldn't need any algebra to answer any angle measurement in this picture. It's always 45, 45, 90, 90, piece of cake. Once you're done, check in the notes with me and you can move on to the homework. Well done. Again, complete all the problems in the notes section, then check in your notes for classwork credit, and then you can move on to the homework.